So we're going to go through one example of each of the problems on your plotting linear functions and plotting exponential functions worksheet. So for this first one, it asks us to make a chart of values for this set of points. So we should recognize that all points always go x comma y or x f of x. So our chart should start with x and we'll put y, but you can also put f of x. Our x values are -2 right here, -1 right here, 0, 1, and 2. So our chart should contain all of those values for our x's. And then for our y values, our chart should contain 4 with the -2, 1 with the -1, -2 with the 0, -5, and then -8. And the next thing it asks us to do is to plot each set of points. So we're going to plot all the points. So first we're going to plot the point -2, 4. Since the x value is -2, we're going to go to the left 2 from the origin. And then the y value is 4. So then we'll go up 4 units. So left 2 and up 4 units. Then -1, 1 should mean left 1 for the -1 and up 1 for the +1. 0, -2 means we do not move left or right because it's a 0 for the x, but -2 for the y means move straight down 2 units from the origin. And then the point 1, -5, we go to the right 1 and down 5. And for the point 2, -8, we go to the right 2 and down -8. And it asks us to draw the line that goes through them. And since this is a set of points and I'm telling you we're going to use an explicit equation to model it, that means that we want to draw an actual line that goes through it. And we want to make sure to remember that whenever we do this, we always put arrows at the ends of our line to indicate that it continues going on and on forever. When we want to write an explicit equation, we need to remember that in order to do that, we need things to go into the form y equals mx plus b. So our b value, as we remember, is always the y-intercept. That's the value in x is 0. So in this case, b is -2 because that's when our x value is 0. Then to figure out what m is, we need to go in and we need to see how much this changes each time. We can see it both in the chart. We're subtracting 3 to go from 4 to 1, and then subtracting 3 again to go from 1 to -2. But we can also see that on each of these points on the graph, to get from 1 to the next, we go down 3, that's a -1, and to the right 1. And -3 divided by 1 is -3. So when we look at it on the graph, it's rise over run. Right? And if we look at it in the chart, we just figure out how much we're adding or subtracting each time. So if m is -3, our equation should become y equals -3x minus 2 because b was -2. So that's how you should do the ones that are explicit linear equations. So for this next one, I'm giving you a sequence and telling you that this is an arithmetic sequence. Right? First, we're going to make a chart of values. So our first value is 2, our second value is 5, and our third value is 8. So when we make our chart x, and this time we'll use f of x, it doesn't really matter. Our x values are the terms of the sequence, the first term, the second term, and the third term. And the f of x values, or the y values, are what the actual sequence numbers are. So that'd be 2, and then 5, and then 8. And so we're going to plot these on our x, y axis, and make sure you always remember to put your x and your y on your axis. An x value of 1 means we move to the right 1, and an f of x, or a y value of 2, means we move up 2. For 2, 5, for the second point, we'll go 2 over and 5 up. And then 3, 8 means we'll go to the right 3 and up 8. Now this time, since we've just got a bunch of sequence values. There's nothing in between them. There's nothing for like when x is 1.5. So we're just going to leave just those 3 points plotted, and that's a good enough graph for this recursive sequence. And then if we're going to write the recursive equation, we'll remember that for a linear, that's f of x equals f of x minus 1 plus m, with either f of 0 or f of 1 equal to something. In this case, because we don't have a 0, we're not going to go backwards and find a new point that wasn't part of our sequence. So we're going to use f of 1 here. So our equation should look like f of x equals f of x minus 1 plus however much we go up or down each time. Well, we go up 3, and then we go up 3 again. So plus 3. And our f of 1 value, we should be able to see it from the chart. F of 1 is equal to 2. And that's what the final result for this problem should look like. So this will be the first one in the exponential problems. This one's going to be an explicit exponential. So we're starting with 0, 0.5, going to 1, 2, and then to 2, 8. We can see that there's not a specific number we're adding to the y's each time. So let's start by making our chart. So here's x, and I guess we'll do f of x this time again. We have x values of 0, 1, and 2. Those are our first values in each of the coordinate pairs. And then we have 0.5, 2, and 8. Now, if you're not sure how much we're going up by each time, you can always take one of the terms, let's say 8, and divide it by the term before it. So if we do 8 divided by 2, we get 4. And so it seems like to go from 2 to 8, we should be multiplying by 4. And we should check and make sure that if we multiply 1/2 by 4, we get 2, which we do, right? You have a half, and you have 4 halves, that should make 2 wholes, right? So 1/2 times 4 is also 2. So we can see that our common ratio here is going to be 4. And our b value, we should see, is going to be 0.5, because that's the value when x is 0. So we're ready to plot the points, draw the curve, and write the explicit equation. So the first point, the x value is 0 and the y value is 0.5. So 0.5 is a half. So that's going to be halfway between 0 and 1. Then we'll put in the point 1, 2. And then we'll put in the point 2, 8. And we can see that this doesn't make a line, it makes a curve. It's a curve that gets really steep really quickly. And as we've talked about in class, what happens over here is it gets really flat really quickly, but it never gets to be less than 0. So your graph should look something like this. And we'll remember that our equation form is y equals b times r to the x. And so we have all of those things already off to the side. We can write y equals, or f of x equals, y equals 0.5, our b value, times r to the power of x. And for this one, we're going to do a recursive graph. So we have a recursive sequence that's given to us. First, we'll make our chart of values. 2 is the first term, 6 is the second term, and 18 is the third term. So when I make my chart, the x values are the term numbers, 1, 2, and 3, and the f of x values are 2, 6, and 18, the values of our sequence. Let's plot the points. So x equals 1, y equals 2, okay, to the right 1 and up 2. Then x equals 2 and y equals 6, that'd be to the right 2 and up 6. And then 3, 18 means we go to the right 3 and up 18. We can see that these are getting really, really big really, really quickly, because each time we are multiplying by 3. And if you weren't sure about that, you could always do 6 divided by 2 to see that it's 3. And then you want to check and see, oh, yep, 6 times 3 is 18, right? And so it looks like we are multiplying by 3 each time. When we have just a sequence of numbers, we're not assuming anything in between the numbers, or we're not assuming any extra numbers before the 2. So this is a good enough graph for us. We're not going to connect the points. It's just a series of points. And so our equation here should be f of x equals f of x minus 1 times our common ratio. And then normally it's with f of 0 or f of 1 equal to something. Since we don't have an f of 0, we'll use f of 1. And we saw over here that the common ratio was 3. We're multiplying by 3 each time. So our final equation should look like f of x equals f of x minus 1 times 3 with f of 1 equal to 2, because that's the value when x is 1. So that's an example of each of the different types of the problems on the plotting linear and plotting exponential sequence and function worksheets. So hopefully you should be able to get through all of those. You're going to see some problems very similar to these on the next test.